Hello. So I'll be doing this mathematical physics questions, all the topics of mathematical physics of related to CSIR JRF. I'll be starting questions from 2019 December till 2015 June. Whatever questions has been asked in the topic, in the respective topic, I will be doing those questions only, and relevant concepts. So here is our first topic on the mathematical physics. You can go through the syllabus of the CSIR on the respective site. So I'll be telling you about the topic now. I'll be doing the questions. So first question is from 2019 December. It is from the part C. So it carries 5 marks. So it is a very easy question. You will find it very easy. So let's go through the question now. Following a nuclear explosion, a shock wave propagates radially outwards. Let E be the energy released in the explosion and rho be the mass density of the ambient air. Ignoring the temperature of the ambient air, using dimensional analysis, the functional dependence of the radius r of the shock front on E, rho, and the time t is. So now r is being dependent on what factors? R is dependent on E, rho, and t, and there might be some powers, right? So I will put those powers as a, b, and c. So now what is the dimension of r? Let's write the dimension of r, that is length. We always write the dimension in the braces, in the square bracket. E is the energy, ml square t to the power minus 2. T is the time, which is written as like this. Now we'll substitute, and lastly rho, sorry, I forgot that is m l to the power minus 3. So now we will substitute these values in the above this part. Okay, so now what we will get is this, which is proportional, not equals to, since there is no proportionality constants yet introduced. So here is what we get, and rho is ml to the power minus 3, that is b, and t is time, t to the power c. Now we will sort this out. We will keep all the values of m on one side and l on the other, and t, then we will sort it out. So here is the sorting. Okay, L is 2a minus 3b, right? T is minus 2a plus c. So now here you can see, comparing on the both the sides, RHS and the LHS, right hand side and the left hand side, what we notice is as L has the power of 1, so L here is 2a to the power 2a minus 3b. So we will equate these equations, and a plus b is 0, since there is no equation, there is no term of m on the left hand side, and there is no term of t also. So equations will be as follows: a plus b is equals to 0, 2a minus 3b is equals to 1, and minus 2a plus c is equals to 0, right? B is equals to minus a. Here we will substitute, and you can get the calculation done, since it is easy. So 2a plus 3a is equals to 1. Here I have substituted. The a is equals to 1 by 5, and my c is equals to 2a, which is to be 2 by 5, and b is minus 1 by 5, right? Now we will substitute in this one. What we will get is e to the power, what is that, 1 upon 5. Rho is minus 1 upon 5, and t is 2 by 5. So here is the answer. You can check the option in whichever paper you are referring to. Now another question from the dimensional analysis. that is from 2018 December part A. It carries obviously 1 or 2 marks, probably it must be 2 marks. Then so here I read out the question. In the attractive Kepler problem described by the central potential Vr is equals to minus k by r, where k is a positive constant, a particle of mass m with a non-zero angular momentum can never reach the center due to the centrifugal barrier. If we modify the potential to Vr equals to minus k by r minus beta by r cube, one finds that there is a critical value of the angular momentum Lc, below which there is no centrifugal barrier. This value of Lc is. Now what we will do in this question is by taking the concept of dimension analysis. Since we have already started in 11th or 12th, basically in 11th dimension on the chapter of dimension analysis only, whatever is the this dimension of the quantity in the left hand side, whatever unit is there in the right and left hand side, same unit is followed in the right hand side also. So each term has the same unit of as potential. So minus k by r will have the unit as potential only, beta by r cube will have the potential as potential only. Since two same quantity can be added and subtracted, so this is the only concept that is being used. Okay, so now here we go. What we will do is, since here you can see from the options there is k m square beta, k m square beta, k m square beta, and k m square beta. So what we will do is we will find out the value of k beta, and then we will put into these equations, and we will find what suits best for the this angular momentum, what can be found from these. Okay, so now since we know what is the dimension of angular momentum is represented by L, and it is r cross p. So its dimension will be m t to the power minus 1, and this is ml square t to the power minus 1. Okay, so now from k by r is this is equals to ml square t to the power minus 2, since it has the same unit as the potential. So we have written this thing. This is the dimension of potential. So k will have the r is length, so this will become ml cube t to the power minus 2. Okay, so this is k. Now beta by r cube is ml square t to the power minus 2. This is beta, and this becomes ml to the power 5 t to the power minus 2. So here we have got k, and here we have on the other side we have got beta. So now we will put the values in the k m square beta, since it is common in all the options. So we will sort this out, and this is as follows. What is m square? This is mass. Is it mass? Yes, it is mass. M square m l to the power 5 3 to the power minus 2. So now we will do the final step, which is this. So what you can find here is, if you look at this equation and this equation, now in order to get from this equation this particular dimension to this dimension, what we need to do is take the 1/4 power, 1 by 4th, 1 by 4, then we will reach to this particular dimension. So whatever equation will be having 1 by 4 as their power is the correct option for the angular momentum. So we have done this equation by eliminating the options basically. So here is the answer. Next question. This is from 2017 December, which is as follows. The normalized wave function in the momentum space of a particle in one dimension is phi p is equals to alpha by p square plus beta square, where alpha and beta are real constants. The uncertainty delta x in measuring its position is. So what we see here is, since we already know from the dimensional analysis this concept that same quantity can be added. Okay, like if momentum can be added to another quantity which has the unit of momentum, right? So p will so beta will be having this beta will have the same unit as p. So here unit of p will be so dimension of p will be sorry to say unit, I would say dimension will be the perfect word. Dimension of p is equals to dimension of beta. Dimension of beta. So dimension of delta x will be equals to what? Delta h cross by delta p. So we know that the dimension of delta p is of beta. So whichever option will be having h cross by beta specifically, not any other function, not even alpha, not any other thing. Okay, so that will give the answer. So this is the answer. Next question is from 2016 June. Using dimension analysis, Planck defined a characteristic temperature Tp from powers of the gravitational constant g, Planck's constant h, Boltzmann constant kb, and the speed of light c in vacuum. The expression of Tp is proportional to. So here the dependence of the characteristic temperature is given, which is as follows. Tp is directly proportional to g, h, oh sorry, these are not the dimensions, so I will do it like this: g, h, kb, and c. Here g is the gravitational constant, h is the Planck's constant, kb is the Boltzmann constant, and c is the speed of light in vacuum. So here we know that the temperature, characteristic temperature's unit is Tp is theta. Okay, g has the dimension, you can calculate from f equals to gm1 and 2 by r square. I will write directly, I will not waste the time. You can calculate it, it is easy. M to the power minus 1 L cube t to the power minus 2, and then okay, sorry, this one. Now h can be h Planck's constant dimension can be calculated from E equals to h nu, or from h by p, anything. E has the unit of ml square t to the power minus 2, and nu has t to the power minus 1. Okay, so this will become what? ml square t to the power minus 1. So this is the unit of Planck's constant, right? And another one is the kb, Boltzmann constant. Again, it can be calculated from any equation which you wish. Let's calculate from this. E is again ml square t to the power minus 2, and T is the temperature, so theta to the power minus 1 is multiplied only. ml square t to the power minus 2, theta to the power minus 1. Here it is. C is the speed of light, which is L t to the power minus 1. Now we'll substitute. Now G will have some power A, B, C, D. It must be having some powers. Okay, so I have substituted like this. Okay, now we will substitute. What we will get is, I am writing directly, or I shouldn't, I think. Here's the theta, which is proportional to m to the power minus 1 L cube t to the power minus 2, which is A, h is ml square t to the power minus 1, B, and kb is ml square t to the power minus 2, theta to the power minus 1, C, and D is L to the power minus 1 to the power D. Now we will sort it out, and we will get the following equations as minus A plus B plus C, right? L is 3A plus 2B plus 2C plus D, and t is minus 2a minus b minus 2c and minus d. And theta is minus c. So theta, if you compare from the left hand side, it is c is equals to minus 1. Okay, minus a plus b plus c is equals to 0. Okay, fine. 3a plus 2b plus 2c plus d is equals to 0. Minus 2a minus b minus 2c minus d is 0. So what we will find from here is a plus b is equals to 0, and from here it is minus a plus b is equals to 1. Put this here equals to this from this, and this is that equation. So what we will get here is 2b is equals to 1, b is equals to 1 by 2. So b is 1 by 2. Similarly a becomes minus 1 by 2, and d will be, put this in any form, if you put in this, it will become minus 3 by 2 plus 2 by 2 minus 2 plus d is equals to 0. So here is the equation. It is minus 3 by 2 plus 1 minus 2 plus d is equals to 0. This becomes d equals to 5 by 2. You can solve it. I am leaving the part of mathematics, basic mathematics. Now the last question from the dimensional analysis from our 10 years analysis is from 2015 December. In the scattering of some elementary particles, the scattering cross-section sigma is found to depend on the total energy E and the fundamental constants H, Planck's constant, and C, the speed of light in vacuum. Using dimensional analysis, the dependence of sigma on these quantities is given by. Now it is just an obvious question, right? Most easy one. Hold a second. I think I should have written in the last one all the values which I forgot. Tp is g to the power minus 1 by 2. H is 1 by 2. H to the power 1 by 2. Kb is minus 1. C is 5 by 2. Now we will rearrange it. This will become H C, all the common powers of 1 by 2. I'm taking this one. C to the power 5, and G goes down, and Kb is 2, Kb square, right? Kb square. Now all has to be in the under root. So equation becomes as this. So equation 1, option A is the correct, option 1 is the correct answer. Now the question which I have already read out to you. In this question, scattering cross section depends on Planck's constant, H, C, and E, and some of their some powers, A, B, and C. Okay, now we already know what is the dimension of H. H dimension is m square t to the power minus 1, right? C is speed of light, L t to the power minus 1. E is ml square t to the power minus 2, right? Now substitute in these equations. Now one more thing, scattering cross section sigma has dimension of area. Okay, so you can write this as, one should remember this thing, scattering cross section sigma has dimension of area, that is L square. Remember this one. It is most important one. Okay. So here we go. Now we substitute all these dimensions into this one. We get ml square t to the power minus 1 a l t to the power minus 1 b ml square t to the power minus 2 c, which is as m to the power a plus c l to the power 2a plus b plus 2c t to the power minus a minus b minus 2c. I hope I am correct. Let's see if I mess up. We will know. A plus c is equals to 0. 2a plus b plus 2c is equals to 2. We will compare from LHS and RHS. This and this side, I mean. Minus a minus b minus 2c is 0. Right. What we will obtain from here is solve these two equations. We get a is equals to 2. Right. This will cancel, this will cancel, this will cancel, this will cancel. Okay. Now a is 2, c becomes minus 2 from the first equation, this one. Right. Now if we know the a and c, we can put this in the above in this second equation. What we will get is 4 plus b minus 4 is equals to 2. So b is again 2. Now put sigma is directly proportional to what? H to the power a, which is 2, h square, c to the power b, which is 2, again e to the power c, which is e to the power minus 2. Right. So we will have equation of the form hc by e whole square. I hope I am correct. Yes, option 3 matches here. So I will be dealing with another topic from the syllabus. I will be going in the same order as the syllabus has been mentioned on the site. So there will be no confusion of what I will be putting next. I will be touching this mathematical physics, and I might touch other subjects also. So stay tuned with my YouTube channel. You will see more from CSIR-JRF, or something which you need, you can tell me. I will definitely like to touch that topic too. Thank you for watching. Take care.